Algebra 1, Common Core, the June 2016 Regents exam, the Part 4, the last question, number 37. Here we go. Franco and Carol went to a bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. Carol bought 2 packages of cupcakes and 4 packages of brownies for $24. We want to let X equal the price of 1 package of cupcakes, and we're going to let Y equal the price of 1 package of brownies. So write a system. Remember, system means multiple equations with multiple variables that describes this given situation. So Franco bought 3, so we look at Franco again, 3 packages of cupcakes, 2 packages of brownies for 19. Now that we know we want X to be cupcakes and Y to be brownies, that's going to translate to 3 cupcakes, 2 packages of brownies, and it cost him $19. Where Carol was 2 packages of cupcakes, 4 brownies for $24. So that's 2 cupcakes, 4 brownies for a total of $24. So write a system, check, done. Now they want us to solve it. Now we could solve this algebraically, like get an additive inverse, maybe multiply this by -2, cancel things out. And we could always do that to verify our answer, but they want us to graph this. So on the set of axes below, graph the system of equations. Now these are linear equations, right? There's no x squared, there's no absolute value, there's none of that. Nothing's being raised to the x, right? It's not an exponential. It's just a regular linear function. Everything's degree 1. The linear functions are, y equals mx plus b. So we got to get the y alone for each of these. So first let me work on Franco here, what I wrote here in blue. So let's get y alone. I'm going to carry this over here. So the first thing to get y alone is move the 3x. So I'm going to subtract 3x to the other side first. And so I'll still have 2y on the left, but then I'm minusing 3x over here, and I still have a positive 19 on that side. And maybe you might be tempted to write 19 minus 3x when you minus 3x over here. But remember, the mx plus b pattern has the x coming before the constant. And then to get y alone, I got to divide by its coefficient to end up with a final thing here. Y equals -3/2 x plus half of 19. That's not going to be a nice whole number and fun to graph. So, what exactly is half of 19? You can certainly use your calculator, but let's see. Half of 20 is 10. And, it's 1 less than that, so I think that'll be 9.5. It's half. You can double 9 at 18, and double the 0.5 to get 19. So this is Franco's equation right here. And let's see what the for Carol. Let's see what happens. So again, to get the y alone, we'll minus the 2x here, minus the 2x. But again, I want to put that in front of the constant 24. So y equals the -2x I put over there, and the plus 24 that was already there. Divide everything by 4. Divide by 4. This one's a little bit cleaner. Now, -2 over 4, I could simplify it to be -half x plus 24 divided by 4 is 6. So that one's a little bit neater. So if we want to graph these, the y-intercepts, the first thing you want to look at here, this one's 6, this one's 9.5. So if I look at my y-axis here, 1, 2, 3, 4, 5, 6, 7, 8, 9.5. So that's what we're going to have to do for this one. Let me graph the green one first. It's going to be a little bit simpler. So starting at 6, 1, 2, 3, 4, 5, 6. Slope of -1/2, so down 1 over 2. And it's a declining slope. And use your ruler or your straight edge. Hopefully not the side of your calculator because it's not very straight. Students like to try to use it anyways. Draw a straight line as you can. Throw some arrows on the ends and label its y equals -1/2 x plus 6. Okay, so how about the more difficult one, Franco? His name's Franco, right? Yeah, Franco. So 9.5 is not a really very good y-intercept for us to work with here. Now that is here And we're going to go down 3 over 2. And we can keep working with the halves. It's going to be like 1, 2, 3 over 2 is probably going to be here. But if we're not really sure, luckily we have a piece of technology that helps us graph things called the graphing calculator. So if we type into our graphing calculator this equation, negative 3 halves x plus 9.5, it can give me a table of values that I can kind of use to verify I'm putting things in the right spot. 0, 9.5, 1, 8. So you see that there are some whole numbers on here, and that might be more useful than the decimals, like 1, 8. So let me go to 0.18. 1, 2, 4, 6, 8. So 1, 8. And I can always from there use my slope to get the rest of my points. Down 3 over 2, down 3 over 2. And then that looks like it's about it. Let me just check on my calculator to see if I'm plotting these points right. Like, is the point 5, 2 there? Yeah. All right, so that's pretty good. And we can draw this line now. I think we have enough. I'm going to change the color to blue. On the Regents, you're probably doing everything in the same color, but that's okay. Something along the lines of that. And again, throw some arrows on the ends and label. This one I'll label y equals negative 3 halves x plus 9.5. I'm surprised they gave a y-intercept that started at 9.5, but anyways, here we are. So now they say determine the exact cost of 1 package of cupcakes and 1 package of brownies. I think this would have been much easier if we just solved it algebraically. The intersection here, I guess, is kind of the solution. But again, I don't really love this intersection point. It's kind of like in the middle of a box. So I'm going to choose to solve this the other method, the algebraically way, and I'll run through that. But we'll see if this graph makes sense once I do that. So if I write down the original equations I have, not the y equals ones, and 2x plus 4y equals 24. I want to get an additive inverse, and so the way I'm going to do that is here in the y column. If I multiply this whole thing by negative 2, I'll end up with negative 4 over 4. But that's going to change the whole equation. It's going to change it to negative 6x minus 4y equals negative 38. And that's now over 2x plus 4y equals 24. And if I'm going too fast, please pause the video and catch up. Just double check, doubling 19 is 38 times negative 2. So I distributed that negative 2 into that whole thing. And now I have an additive inverse column. My y's will cancel out when I add these together. Negative 6x plus 2x, that's negative 4x. These cancel out, equals negative 38 and 24 combined to be what? Negative 14. And then we just have to divide by negative 4. I'm sorry, it came out a little sloppy. Divide by negative 4. And so what is x? Negative 14 divided by negative 4. Again, it's a decimal, but that just means that it's not exact to the dollar. So negative 14 divided by negative 4. Now we know a negative divided by negative is positive, so it's no mystery. The answer is a positive, and it's 3.5. So that means x equals 3.5, which means the cost of brownies is $3.50. And that 3.5 is what we see here, 1, 2, 3.5. That is the x value of this coordinate, 3.5, comma, what? Comma, well, it looks like 1, 2, 3, maybe 4.5, but I'm going to verify that algebraically also. And the way that I'll do that is I'll just, take this bottom equation, 2x plus 4y equals 24, but now I know x is 3.5. So instead of 2x, I'll do 2 times 3.5 plus 2y equals 24. 2 times 3.5 is 7. Plus 2y equals 24. Minus that 7 away. 2y equals, 17. And then we're going to, I'm sorry, I made a mistake here. This is 4y. Let's see if I can get a small eraser and check. This is supposed to be 4. I apologize. 4y. 7 plus 4y. So minus the 7, we get 4y equals 17. Divide by 4, and y equals 17 divided by 4. And we'll see if our suspicion of 4.5 is right. 17 divided by 4 is 4.25. Oh, so we were close. See, that's the tough thing about this question. Sorry, I lost my screen there for a second. Is they ask you to graph it, but then the graph's not really that useful. So the cost of one cupcake is $3.50, and the cost of, remember again, this is your cupcake cost, and this is the brownie cost in dollars and cents. But like I said, looking at this, I mean, I guess you could kind of see that this isn't exactly 4.5, but that's tough to ask you to graph a question and then not have the graph really, clearly show what the answer is. But luckily, we know we could do it algebraically, and that really kind of saved the day on this question. So that's number 37. That's the part 4. That's the big one at the end of the test. So this has been the June 2016 Regents exam. I hope you've enjoyed the ride. See ya.